Oh, okay, let's come back to look at checkpoint. Okay, I think my walkthrough for this checkpoint will stop here, but there are a lot of interesting things, okay, and as you can see, a lot of good illustrations here. Okay, that's sometimes very helpful for the site engineers or site managers to understand what we are saying. Okay. So itself, this book is a very good materials to train the on-site engineers. Okay. Okay. Now for this one, okay, so please try to read through them, okay, and in this course there are two projects that I require you to do. One, the first project will be related to this checkpoint for this semester, okay, and one thing is you'll be divided into groups, okay, and I want you to present these checkpoints. How many chapters are there? We have materials, handling, storage and handling. We have hand tools, machine safety, workstation design, lighting, premises, hazardous substances and agent welfare, facilities, work organization. Okay. 9? Some of them are smaller, okay. Nice. That's okay. 9 groups. How many we have here? Oh, okay. Let's see. I think there are 40 something, right? Let's check. 39. Now we have 39. So 9 groups. Is that possible? 9 groups. Maybe 6. So that means 4 students per group. 4, between 4 and 5. Okay, between 4 and 5. So how about this? Next week. Okay, next week, please divide yourself into 9 groups. Minimum 4. Okay, maximum 5 people in a group. And next week, please, write it down on a piece of paper, okay, and then give it to me, okay. And I will give you. We are still waiting for some students to join us, okay. I will give you how to present this, some guidelines, okay. You can download this course materials from the Moodle, okay? Okay, I think I'll start over with the introduction very quickly. Okay, ergonomics, okay, is a scientific discipline concerned with the fundamental understanding of interactions, okay, among humans and other elements. Okay, so the very important thing is the interaction. Okay. Among people and other things, all other things, everything. Okay, including including environments, okay, jobs, systems, methods, and also materials, machines, tools, okay. And ergonomists are the people who do this job, okay. And there are professional ergonomists in EU, also in part of the US and in Japan, okay. And these are probably 3 areas that have ergonomist kind of position or certified position, okay. That's ergonomist. In general, who are doing ergonomics? In general, industrial engineers, okay. Okay, so the interaction occurs between humans and tasks, jobs, products, environments, okay, and methods. Everything you can think of. Okay, so what we have to do is to try to understand the needs, the abilities, and limitations of people. Okay, I think we covered this before. Okay. Ergon means work, nomos means laws, okay, so ergonomics has the meaning of laws of work, okay. And then we consider physical, cognitive, and social, and even organizational and environmental. So these checkpoints are also organized into into similar ways in each chapter, okay. And to actually do research into ergonomics, it requires many, many different areas. Epidemiology, physics, because of biomechanics, because of energy kind of study, chemistry, because of biochemistry, mathematics, that's general, because of statistics, right? Psychology, biological sciences, engineering and technology. So ergonomics is a multidisciplinary area, but basically this specialized scientific field is mostly within industrial engineering. And the idea is interaction. So we study human machine interaction. Machines, here we refer to general kind of machine, tools, method, workplace. So we study the interaction between human and the machines, and also because human plus machine are under the environment, the work environment. Basically, there are something we call physical ergonomics, and that's what we are going to do here this semester. Trying to understand human anatomy, human size, human dimensions, that's anthropometric, and physiological and biomechanical characteristics. And the relevant topics including working postures, materials handling, repetitive movements, work-related musculoskeletal disorders, workplace layout, safety and health, as you have seen in the IL checkpoints. And there is another area which is called cognitive ergonomics. And we do have another course, in this department for this. And that is concerned with the mental processes, such as perception, memory, cognition, etc. And the relevant topics include mental workload, decision making, skill performance, human-computer interaction, work stress, etc. In general, the third category, we call it organizational ergonomics. Concerned with the optimization of socio-technical system. What does that mean, socio-technical? What is a socio-technical system? Why doesn't it say human technical system? Human technical system means one person. Socio-technical system means a group of people. And what is a group of people? Organization. Whenever you have more than two people, you have an organization. So, physical ergonomics is about one person. Its relationship between this person and all other things, environment, machines. Cognitive ergonomics again is about one single person. The study of this person the interaction between this person and all the other things, but mentally, cognitively. Organizational ergonomics study a group of people. We call them organization. The interaction between this group of people and all the other things. Okay? But if you look at the topic, communication, crew, management, work design, teamwork, participatory design, cooperative work, and management. Yeah, it's indeed very managerial. This kind of thing is also covered in business administration. They call it human resource management. So indeed, organizational ergonomics is highly related to human resource management. If you look at the crew resource management, what is crew resource management? CRM. Whenever you have a situation, group of people have to work together to complete a very critical task. For example, in a nuclear power plant, there is a control room. The control room, okay, usually there's only 3 to 6 people working there. Okay, this is a typical nuclear power plant control room. As you can see, very complicated. There are so many computers, so many control buttons, so many functions, so many displays. Yet, as you can see, how many people? 3 to 6. What do they have to do? What do they have to do? They do nothing. Tell you the truth. However, if there is a critical situation, our lives are very dependent upon these 3 to 6 people. The entire city. If there's a nuclear power plant located near your city, near where you live, these 3 to 6 people are one of the most critical people. A nuclear power plant is fully automatic. But we know, everybody knows, a fully automatic thing, a fully automatic system sometimes break down, sometimes have problems. It doesn't run completely by itself. No, it's not the truth. fully automatic is only fully automatic. A person for percentage of time. It's not 100%. Whenever it says, whenever I saw something 100%, 100% fruit, 100% apple juice, 100% orange juice. Look at it, it's not 100%. It only contains 10%. What it means is only this 10% is 100%. Real apple. It adds water. There's 90% water. Same thing. This plant, this factory is 100% automatic. It's alive. It only tells you a percentage of time. If everything goes well, it's 100% automatic. But there are downtimes, there are problems. Who are going to take care of it? These 3 to 6 people. And they have to recover. They have to recover from those emergency situations as soon as possible. Otherwise, the whole city will be dead. Now, if you study the communication between these 3 people, the interaction, work with all these complicated computers, these are called organizational ergonomics. Another situation, let me tell you, is the cockpit. Here. How many people working in the cockpit? You know this, right? How many? How many passengers? Can be 300, 200, 500. How many lives? You're talking about so many lives under the control of these 2 people, sometimes 3. 3 pilots, sometimes 2. What are they doing? Again, I can tell you, 100% automatic. They are doing nothing. That's what you have heard about, right? Some of them, they are just drinking coffee and then taking a nap. Extremely boring if nothing happened. However, we know the 100%, the 100% automatic is not true. During the entire flight, there will be sometimes you hear buckle up, okay, fasten your seatbelt because we are encountering turbulence. When turbulence comes, these people begin to be engaged. We call that engaged. Begin to work, trying to pass through. There are kind of emergency situations. The machine sometimes will have problems. So when you study the interactions that include communication between these 2 guys, communication between the monitors, the displays, the interaction between the seat, the control, it's not a mouse. How to design the workspace, work area for them. These are ergonomics. But we are talking about a group of people, ergonomics. That's organizational ergonomics. The future is even more complicated because this is very important issues in ergonomics, in human factors research. In the history, human factors, ergonomics, okay, we do a lot of research for these kind of situations. Communications. Imagine this. If now there's a big problem. Cockpit, this guy, the pilot, two pilots here, we probably know this guy is white, gray hair more. So he is younger. So this may be the pilot. And this second one may be the co-pilot. Co-pilot. Okay, and the design is like this. Okay, the co-pilot have everything here and here. The pilot will also have everything exactly the same, identical. It's two redundant systems. Two redundant systems. It's like two people are driving in the same car. The pilot has one driving wheel. The co-pilot will have his own. Replication, dual system, very good reliability. Now, imagine this. There's a problem now. And the co-pilot, the pilot, usually the pilot will, like, I'm old, right? Senior, so I'll take a rest. Let me take a nap. Go ahead. And if anything happened, tell me. And then I was woken up, a problem. And I look at this monitor, what problem? Tell me. And then I said, do this, do this. But I just woke up, do this. And then so co-pilot said, no, we only have 3 seconds left. Let me tell you, we need to do this. And the pilot said, no, trust me, I have more than 10,000, 100,000 hours of experience. Who is the pilot? You are just co-pilot. You have to listen to me. And then now 1 second left. And the co-pilot said, no, we have 1 second. You have to listen to me. And crash. That's the scenario. And that happened. And happened again and again. Even when both of them are not asleep. Everybody's awake. There's a new situation. Who is the boss? So you have to set the hierarchy. However, sometimes the co-pilot is right. Sometimes pilot is right. They have to make decision. So this is the kind of situation, decision making. Teamwork. Again, teamwork, right? Cooperative work. Okay. In the future, human-machine collaboration will be a big issue. Just imagine this. They are not just working with machines. They control the machines. In the future, there will be one pilot. There will be a co-pilot, 2 people working. There will be another people. You call the people robot. There will be a robot sitting beside you or hidden inside that cockpit somewhere. And then the problem occurred now. And then the robot will say, because the robot has AI, and human doesn't have AI. Human has only human brains. And supposedly, AI is much smarter than human brains. That's about 10, 20 years later. The situation, 20 years later. Most people think AI is smarter than human brain, right? Would you agree? 10 years, AI will be smarter than human brain. No? Yes? In this field, in this area, in the cockpit. So the same situation occurs. AI will say, no, you are sleeping. Listen to me. 1 second left. Listen to me. Believe me, trust me. And the pilot say, no, I have 20 years experience. How do you solve this problem? Who has the hierarchy? Who should listen to who? You have to make decision within 3 seconds, 1 second. If you say AI always have, AI should be the boss always because we think this is better in that situation. In this case, you don't need these 2 people. We can save a lot of money. You just fire them. You'll just take the airplane with no people, with no pilots, right? Because AI always win. You trust the AI, so why do you need these 2 people? So that's going to be the future we are facing eventually. Okay. But that's not the main theme of this course. Let's come back to physical ergonomics. One person ergonomics. In physical ergonomics, we are concerned with the design, modification, replacement, maintenance, equipment for enhanced productivity and the work life and product quality. And quite often what we are doing is for the workplace layout. And for the ease of use of the tools, the machines. We also design and change working methods. And finally, we also design and change and try to control environment such as heat, temperature, cold, noise, radiation, vibration, in order to protect the workers. And there are a lot of stress factors. I have already demonstrated to you, even as simple as the classroom. It's complex. There are a lot of functions intended for. For every function, will always be control. There will always be buttons. And we are always being exposed to this kind of complexity. Similarly, the tools, so many tools people have to use, so many buttons. And then we also have thermal conditions. We have noise condition, vibration condition. We have lighting, illumination. We have toxic materials we have to handle. Okay, and then we have workload problems. Okay, so these are the things that we have to take care in ergonomics, in physical ergonomics. Okay. And all these affect workers. We are not saying causing problems, because it's difficult to 100% prove their causal relationship. But now we understand, even when we say cause, this cause that problem, we don't really mean cause. We have to be careful. We don't really mean a true causal relationship. We just mean it's because it's difficult to verbally describe that relationship. Okay? When we say affect, that's probably more true. These factors do affect the workers. Okay? Okay, now we'll try to understand the human anatomy. Okay, because these information are important for us in order to be able to evaluate whether a tool or a machine or the workplace are properly designed for workers. Anatomy is the understanding of human body. Okay? Human body has all these structures: muscles, bones, tendons, ligaments, okay, and others. Just trying to know all these are something very, very complex, because human body is very complex. There are 206 bones. Okay? So it's a big system. Just trying to name each of the bone is already a tremendous job. So this system is big, is huge, is complex. Yet, trying to understand how these different muscles, different bones, different organs, different tendons, ligaments, these are just skeletal part. We have lungs, we have hearts, we have eyes, we have blood vessels, we have so many things. Trying to understand how they work together, how they function together, is physiology. Okay? How the temperature is regulated. Why do we have to understand how the temperature is regulated? Temperature regulation. Why? Why do we have to understand? Because there are workers working in such a environment, such as cold. What kind of workplaces are they? Yeah, low temperature logistics now very popular. The poultry you buy from the supermarket, grocery store, they're always processed under 5 degrees Celsius. The worker have to wear a lot of things, right? Meat processing, poultry processing. Unlike traditional market, they outdoors, they can do it without temperature control. Today, in the factory, in the industry, meat packing industry, meat, low temperature logistics, the milk you drink comes from the kind of low temperature workplaces. How about heat? What kind of workplaces have problem of heat? Okay, steel. The burner, the fire, heat. You have to find a way to cool down those people. What else? You think those steel manufacturing, steel company, they are low tech? How about high tech? Do you think high tech is always like this? Temperature control? Yeah, there are a lot of different sectors we never imagined, but they exist. How about mining? Mining. In another country, in Taiwan, we don't have mining. It's a small island. We don't have this kind of resource. How about forestry? In the forests, sometimes also when they work, it's a lot of heat. Very hot environment. Outdoors, agriculture. How about agriculture? The farmers. A lot of heat. So there are all sorts of workplaces. Hopefully, there will be some companies, instead of making just autonomous car for the driver, they can also make some autonomous robots to help in these workplaces to solve the problem for us. So this is very ironic. On the one hand, we are able to invent autonomous car. But actually, as human being, we love to drive, right? That's why you buy the race car, right? You spend a lot of money. Why do you buy a car that you cannot drive? But on the other hand, if they are so good, why don't they develop something that can really work for mining, for agriculture? Indeed. They begin to do this. That's good. But then not enough. For these dangerous or unfavorable kind of workplaces, I think we need to do some more. That's kind of ironic. All right? We are waiting for them. And okay, there are a lot of things that we will cover, but some of the things we don't have time to cover, okay? Because this takes at least 1 year to cover all the physiology, okay? In medicine training, physiology is very important, right? You have to understand the metabolism. We'll cover part of this. Muscle mechanics, we'll cover part of this. Oxygen, okay, we'll cover part of this. But the nutrient distribution, temperature regulation, nerve transmission, well, we will probably don't have time to cover all this, okay? But we'll try to cover how the muscle work, how the metabolic system works, because these two are related to human work. Okay, this is a very important anatomical position. We do a lot of postures, definitions of postures are based on this. This is called anatomical position. A person actually lies down on the table like this, waiting for the surgeon, the medical doctors do something on you. Okay, so when you lie down, the palm is like that, not like this, not this. Okay, in the army, we are always required when we stand, we have to. But that's the army position, not the anatomical position. Anatomical position is like that. The palm facing forward. Okay? First, we try to identify the body part, body segment. This is the head. This is the face. This is the neck. This is the shoulder. This is the upper arm. This is the forearm or lower arm. Forearm, lower arm. It's missing hand. This is the hand. This is the hand. Okay. Biomechanically, we have definitions. From where to where is called upper arm. From where to where is called forearm. In biomechanics, there are ways to actually make a good definition. But conceptually, we don't need that kind of detailed definition. Only when you are doing biomechanics, you need them. Okay? And this part is called thorax. And this part is called abdomen. About the waist area. Okay, and the upper arm plus forearm is called upper extremity. Upper extremity is consisted of upper arm, forearm plus hand, 3 parts, and part of the shoulder sometimes. So this is upper extremity. Lower extremity is here. Foot. This is foot. Lower leg, thigh or upper leg. Thigh or upper leg. Lower leg, sometimes also called shank. So the entire thigh plus lower leg plus foot is called lower extremity. Okay, looking at, okay, this is called the anterior view. Anterior view. Looking at the front. Okay. If you look at the back, it's called posterior view. Posterior view. Okay. Again, you have shoulder, same thing over here. This is the back. The back also divided into upper back plus lower back. Lower back. This part is buttock. Okay. Okay, now there are joints. For example, this is the elbow joint. Okay, shoulder is also a joint. Wrist joint. And on the hand there are a lot of finger joint. This is the ankle joint. Ankle. Okay, and for each, okay, the lower leg sometimes is also called calf. It's the same, calf or shank. For this lower leg, for example, this is knee, right? Knee joint. This end, this position, this end, there are two positions, here and here, right? This is the entire lower leg. This end is called distal end. Distal end. This end is called proximal end. Proximal end. Proximal means near, close. So this end is closer to the center of the body. That is why this end is called proximal end. This end is far from the center. So that is why this is called distal. Distal means far, distance, at a distance, distal end. Okay? So if I ask you, how about thigh? This end should be proximal or distal? For the thigh, this end should be called proximal or distal? Proximal, because this end is closer to the center. For the thigh, this end will be called distal. Okay, let's try forearm. At the elbow, this end, would you call it proximal or distal? Yes, proximal. Proximal. Why? Again, if you raise your arm, okay, you can imagine this end is closer to the center. You can imagine, you can think of this upper extremity as attached to the human body. So this end of the forearm would be proximal. This end of the forearm would be distal. Okay? How about for the upper arm? For the upper arm, this end, that is shoulder, would be proximal. Proximal. Okay? All right. Now, there are also three reference plans. Reference plans. The one that cuts, that divide the person into left and right is the sagittal plane. Sagittal plane. Sagittal plane. Okay? And we call these reference planes, as long as they are parallel, they belong to the same plane. So there are a lot of sagittal planes. The sagittal plane is the plane that is always parallel to the mid-sagittal plane. There's one, right? Mid-sagittal plane here. Mid-sagittal plane is this one that cuts the person into left and right. And all the other planes in parallel to this mid-sagittal plane would be called sagittal plane. Okay? But in general, okay, when we say sagittal plane, we always refer to the mid-sagittal. The second plane is the one that divides the person into the front and the back. That is called coronal plane or frontal plane, coronal plane. Okay? The third plane that cuts the person into the upper and the lower two halves is called transverse plane. Transverse plane. Okay, so there are three reference planes. Okay, now based on these anatomical position and the three references planes, then we are able to define these terms. These terms occur in ergonomics or in physiology very often, very common. Anterior, we already seen this. Anterior refers to the front. Front. Anything that occur towards or in before the coronal plane, before, towards, away from coronal plane will be called anterior. The meaning is front. Front. So I can say the anterior surface of the thigh. Anterior surface of the thigh. That just means this part. When you try to describe, I put something attached to the surface of the thigh. This is not clear. When I attach something here, I put a EMG electrode the thigh, but here you have to describe it exactly. So you have to say it this way. Just I put something in front of the thigh, on the skin of the thigh. You have to say, I put it on the anterior surface, about 3 inches away from the distal end of the thigh. See how we describe it? Okay, when you attach something here, okay, you have to describe it this way. I attach something about 5 inches, about 3 inches above the knee joint or above the distal end of the thigh on the surface, on the anterior surface of the thigh. If you know how to describe this way, then you are an ergonomist. Are there better ways to describe this? Yes. I think this is still not perfect. Or when you try to describe you are pulling, you are massaging the thigh, that anterior surface. You are pushing up. How do you describe it? You're doing massage, pushing the surface of the thigh. You have to add something more, right? You are pushing them. Yeah, superiorly. Because superior means above, upper. Inferior means below. So when I try to describe this movement, I'm massaging the thigh that way. You can say, I'm massaging the anterior surface of the thigh superiorly. That means you are moving above. Okay, have you seen the movie? What's the movie? The Indian movie, Three Idiots. Huh? The professors ask a question. What is that question? I can't remember. What is mechanics, right? So what is mechanics? Now, what is mechanics? Okay. Academic answers, always like that. So same. You cannot just say, oh, I rub it. I rub it. I push it. No, it's no good. You have to describe it in an academic. That would be a good exam question. I ask you to describe something. Try to use this. Okay, so that's superior, inferior. Else. Medial, lateral. Medial means near the median plane, near the sagittal, close in on, towards this. So lateral means away from this plane, away from the median plane. So if I want to describe, when I play basketball, somebody do this to me and make my arms this way, how do you describe it? What I have done to this, to him. Maybe it's she. Sorry. I pull this arm laterally. Oh, laterally. Right? That's how you use it. Or when I try to describe the lateral side, the lateral end of this rib. Number 4. Median end of this rib. Median. Because it's close to the sagittal plane. Now, if you read the papers, you can understand what they are talking about. How about, we explained this already, proximal distal. For this upper arm, again, proximal distal, okay? Palmar or volar. Palmar or volar, palm. our hand, palm. Inside, palmer. Palmer. Voila. When I say I attach something, I rub some oil here. I rub on the volar surface of the forearm. Palmer. Dorsal. Dorsal means the back. Back. Dorsal. Plantar refers to the sole of the foot. Let me see if he or she can raise the leg. Oh, good. Be careful. This is very good. Yoga. Sole. The sole. The plantar. Oh, okay. This, we explained pretty much everything. Okay. Anterior side of my head. Okay. Oh, sorry. Wrong. Posterior. You're right. Okay. Okay, that will be for today. So next week, please give me a piece of sheet. Write down the group names, individual names for each group. Okay? That's the homework for this week only.